Hi, I'm Ms. Cho. This is lesson 3.7, Identify Arithmetic Sequences. This is a should-do lesson. Our aim today is how are arithmetic sequences related to linear functions, and our lesson objective is I can identify arithmetic sequences and determine the missing terms in a sequence. One thing I like about sequences is that you get to be a detective. So take a moment to pause the video and find out what's the pattern in each of these sequences below. Our first snowflake pattern starts with 5, has 8, and then 11. So if you notice, we're adding 3 snowflakes to each time, so our pattern is add 3. Our cupcakes, we have 16, and then we have 8, and then we have 4. So you notice we're taking half every time, so multiply by half. And finally, we have 4, 9, and 16. This is a 2 by 2 square, a 3 by 3 square, a 4 by 4 square. Our pattern is square the next number. All of these patterns are called sequences. A sequence is a list with a pattern. In this lesson, we are specifically looking at arithmetic sequences, which are sequences that change by adding or subtracting the same amount every time. Based on this definition, which one is an arithmetic sequence? It's the first one, the snowflake one, because the operation is to add 3. Let's explore the snowflake sequence in more detail and introduce some new vocabulary. We talked about sequences being a list with a pattern, and every item on the list is called a term. We have special names for special terms. So our first term is called our initial term, a subscript 1, or you can also see this as a of 1, like a function. My first term is a1, my second is a2, my third term is a3, my fourth term is a4, my fifth term is a5, and on and on and on. If I wanted to know the nth term, then that would be a sub n or a of n. So for example, if the question asks, I want to find my 37th term, then this would be a sub 37. When I look at terms that are consecutive or right next to each other, the amount that they change by, in this case, by adding 3, is called our common difference, or the letter D. This common difference is related to the rate of change that we learned about in lesson 3.2. If I draw a table and I have my n and my a sub n, so my first term is 5, my second term is 8, third term is 11, I can find the rate of change by looking at the changes in the y and the changes in the x's. My rate of change is the change in y over change in x. And at this point, it's 3 over 1, 3 over 1, 3 over 1, 3 over 1. And because all of my rates of changes are the same, I know that this is a linear function. Let's see how we can use this information to solve a problem. In this example, we are asked, are the sequences below arithmetic? If so, find the common difference. Another way of thinking about this question is asking, is the difference between every term the same? If it is the same, it is an arithmetic. If it's not, then it's not. So from -3, how did I get to 0? I added 3. From 0, how did I get to -1? I subtracted 1. From -1 to 2, I added 3, and from 2 to 1, I subtracted 1. So you can see this is clearly a pattern, and I can predict what's going to come next by adding 3 and subtracting 1. But the question is, are these all the same? And the answer is no. Because they are not all the same, this is not an arithmetic sequence. In the second example, I'm going to do the exact same thing. I want to know if all the differences are the same. And with the decimals here, I'm going to use my calculator to help me. So from 37 to 33.5, I subtracted 3.5. From 33.5 to 30, I subtracted 3.5. And from 30 to 26.5, I subtracted 3.5. Because these are all the same, then I know that yes, this is an arithmetic sequence, and my common difference is -3.5. Here we're asked to find the missing term in this arithmetic sequence. Knowing that the sequence is arithmetic is really important because it tells me that the difference between every term is the same. And since I know that it's the same, then my first step is I'm going to find what that difference is. I'm going to take the first two numbers I know and find that difference. 59.3 minus 54.1 is 5.2. So I went down 5.2. Because these are all the same, I know this difference is also negative 5.2 and this difference is also negative 5.2. Since I know that the difference between 54.1 and my blank is negative 5.2, I can add negative 5.2 to my neighbor and find my blank. This means this term is 54.1, the term before it, plus the common difference, which is negative 5.2. And then my calculator, 54.1 plus a negative 5.2 is 48.9. If I wanted to double check and see if this is the right term, I can take 48.9, and subtract 5.2, and it gives me 43.7, which is exactly what I expected. Let's summarize. We've learned some vocabulary, with a sequence being a list with a pattern, an arithmetic sequence specifically having the pattern of adding or subtracting the same amount every time, and that same amount is called the common difference, which we represent with the letter D. Each item in the list is called a term, and our first term is called our initial term, which we write a sub 1 or a of 1, and our nth term is a sub n or a of n. To decide if a sequence is arithmetic, you're asking, is there a common difference? In other words, if I look at every consecutive term, are all of these differences the same? If they are the same, then you have an arithmetic sequence. If they are different, then it is not arithmetic. To find the next or a missing term, you want to find the common difference, because every term has the same difference. And then you will use the term to the left of your blank, the neighbor, and add the D to find your blank.